coming out. I'm going to, this afternoon, be playing around with 4 apps that I am using in my teaching here at Southern University. I teach with a MacBook, an iPad, and whatever else I could get into the classroom. I actually switch off on using multiple devices. We have Apple TVs over in TTL Lane, and I'm just trying to figure out how to incorporate all of that into my teaching and keep the students engaged. So the examples that I'm going to show today are calculus-based because I am all about the calculus. I love it, and I love teaching it, and I'm trying to learn new ways to engage the students in the process. So these apps are basic apps, but I think they're really good for demonstrating some of the concepts in the classrooms. And one of the applications is more advanced, but it kind of engages the students into why they want to learn their basic mathematics so they can do some of the fun applications. So we're going to start off with one that I really like, MathPad. It's called MathPad. Let's switch this. Let's see. So MathPad is a free app, and it's actually a handwriting LaTeX generator. I have it just, oh great, it's up front too. I have it displayed up here on that side over there. What I like about MathPad is it converts your scribble into LaTeX. So it allows me to use this as a whiteboard, use my iPad as a whiteboard, and it translates it into nice script. So chapter 2 of my calculus book is all about limits. So I can scratch down an example that I want the students to work on, and it will translate my scratch into a nice equation. So if I want to throw something up there for the students to work on, I don't have to worry about my penmanship. It's going to come out nicely, and then I can actually work the problem with the students, asking them questions as we go along. So in this example, I asked them, can we use direct substitution? Once they try to use direct substitution, plug in 2, they find out that they end up with an indeterminate form, 0 over 0. So they have to use their algebra. So their next step is to factor the numerator. So I ask them, how do you factor the numerator? And then they give me their responses, and I add that to our page. And even if I'm going off the page, it'll shift things over. And if I mess up, I scribble it out and keep on going. So in the process of working an example, I could do a real-time example with the students, and it's providing me with a nice demonstration of it. Ask the students what's next, canceled, we continue the process, it adds the information, and we finally get to a point where we can use direct substitution. It's all written out nicely. We do the work. Let's see what it does there. And we finally come to the result for, oops, that's not right. I can scribble it out, try it again. And we've evaluated a limit in real time. My chicken scratch has been converted into nice script. What I love about this is that, okay, I've done this example. Now I want to reuse this example. I could save this as an image. So if I'm teaching multiple sections, I could just throw this into a PowerPoint as an image. What I like to do is save it as LaTeX. I could create a handout for the students later on. Here are the problems we worked in class. Please review this information. You will see it on the exam. I could also save it as MathML. So it's mathematical markup language. So if I want to put it on a website, I could put it up on a website. And this generates the code. So what I'm showing you is the code for MathML, LaTeX, or I could just save it as an image, throw it into a PowerPoint. So your work is not in vain. I can do my chicken scratch, work an example, and I can save it and send it to a student. So I use this in class as well as when I'm doing tutorials with students. They come into my office, ask for an example. We work the example on the iPad. I tell them, don't you write, watch me write. So they're telling me what to do, but I'm writing it down. Then I can email them what we worked on. So instead of them spending their time trying to write down what I'm writing, I have them think through what's going on, or I have them actually, doing the scribble on here. It's saved for them, and I can email them the image of it. I normally email them the image because they don't want to have to deal with the LaTeX, but they'll see what we've worked on, so they'll have all the information in front of them. MathPad is great, and it is free. So I use it as a whiteboard. As I mentioned, use it for tutorials. I create assignments, so if students say, can I have some extra problems, I can quickly in class write up some examples, send them home with it, and email it to them, or post it and they'll see it later. And as I mentioned, you can save the work as an image, or LaTeX, or MathML. And of course, this is a free version, so you get a lot of functionality and it's free. The next app that I play around with, so this is just whiteboard, making it nice and pretty for us to read. The next app I want to talk about is a free graphing calculator. And I'm posting at the top the icon for each of these. So the free graphing calculator, as is mentioned in its title, is free. And one thing that I like about it is that it is a scientific calculator. I've already gone into my example. Let's go back. Oh, that's the wrong one. Sorry. Free. Here we go. All right, it's a scientific calculator. So let's first look at the calculator part of it. It's free. So as you see across the top, you get your ads. Free means you have to put up with some stuff. But for the most part in class, what I'm using this for, this part of it, is to demonstrate to the students how to input data. So I've put up an example here. Again, with the concept of limit, I use this a lot when we're motivating the concept of limit. So let's escape just for a moment. And look at an example. So here I do a hands-on example with them. So the example is, what's the limit as x approaches 1 of square root of x minus 1 divided by x minus 1? Again, you plug in 1, you're going to get an indeterminate form, 0 over 0. So now, before the students have actually learned how to evaluate limits, I ask the question, okay, what's the behavior as x approaches 1 from the left? What's the behavior as x approaches 1 from the right? So the students are developing tables of information. So I use this to demonstrate to the students how to appropriately enter the information into their calculator. So we ask what happens when x equals 1, you get an indeterminate form. Great, what do we do? Well, let's plug in some values. So we start a table, and the students provide me with values to include in the table. So we have a discussion, okay, when x is approaching 1 from the left, what values are of interest to us? When x is approaching 1 from the right, what values are of interest for us? So I have them include at least 4 values on each side. So these are the values that are included. And I write it up in this form so that the students see when they're entering this information into their scientific calculator that that you have to put the parentheses around the denominator, particularly and numerator and denominator, to preserve the order of operations. So on the calculator, I've done the first calculation. So I tell them, okay, whatever your x value is, you're plugging in where x is. And this seems like it would be something simple for students in calculus, but I've seen all kind of variations of wrong answers when it comes to just it's plugging in values. They plug in one value for the numerator, another value for the denominator. So this is just to demonstrate, remember what you did in previous math, pick an x value, stick with that x value, find your output. So this calculator is nice to display that. We go in, we plug in the values. So I know to them, you put your parentheses, square root, put in your value, close out your parentheses, and then follow the information provided in the function. So I'm just going to do one more value here.